Okay, good morning. Let's have a class. Today's class will have a two section. First of all, as we talk about a review, we're gonna go over the side chain of the 20 amino acids. And I record it, we'll put on the eCampus and you can review. Then we're gonna do antibiotic resistant, okay? So, first of all, everybody should be very clear. Amino acid. What is the basic structure? NH2. Center is CH and COOH, and the side chain is R. So, NH2 amino group and the amine group COOH carboxy group or carboxy acid even. Okay, so the difference is R side chain. Then the center C, we call it a chiral C. And the only exception is glycine. Is that right? So this is the basic things. And I said in the exam, we had 20 points of extra points, which is a name and also structure. Structure of side chain, because it's all the others are the same. So name will be 0.5 points, 0.5 points for one, and the structure is also 0.5 points for one. Okay? The name could be the full name or the acronym, it's up to you, because you're in a different level. So let's talk about that. The first group.
Can we draw the skeletal structures?
Sure, whatever you like, as long as we can recognizable, that's fine. Okay? So first group is non-polar. And we also call it a no charge. But we will mention there is one of them exception. Okay, so let's go talk about this. First of all, H, that's the easiest one. Glycine, the easiest one. Okay, so that's why it's non-polar. CH3, alanine. You can write ALA, okay, alanine. Then we go a little bit complicated. With a little bit of complicated. CH3, valine. Okay, then we go up. Okay, how are we gonna do it? CH2, CH3, go CH3, that is leucine. Okay, then move the methyl group go down, so we go become CH, CH3, so on the top we have CH2, CH3, this is isoleucine. You can write ILE, okay? Now, then the one, which is chlorine. Chlorine, I usually have to draw the whole thing because it's a circle, so CH, COOH, then go to the top, CH2, CH2, and then we go CH2, go back. So that's chlorine. Then we talk about the one in the classroom, phenylalanine. So we have a phenyl group, and then we with CH2. So phenylalanine. Okay, then phenylalanine, we talk about the deaminase, is that right? Deaminase become phenylpyruvic acids. Then the next one we also talked about before, if you remember. You may not be familiar with the structure, but that's okay. So we have NH. What is this? Tryptophan. Tryptophan. And remember, we talk about this goes here. This part is Indo. Is that right? We have a reagent called Kovac. We can do the test. Okay, when we finish here, this one is a little bit arguments about that. Lots of the textbook put this one as charged. Some of them is still polar, no charge. Cysteine. This is start to have a sulfide group. Then the one you should be very familiar because we talk about CH3S, CH2, CH2. What is this? Methionine. N-I-N-E. Remember, formal MET is the first one to translate it for RNA translation of bacteria, okay? So end up here is the first group, is non-polar, no charge. Then we go second group, is a non-polar, is a polar, no charge. It's polar, it should say polar, hydrophilic, but still no charge. So what are they? The first one, CH2, OH. When you add the OH, serine. Then what? CHOH, CH3. What this one? Serine. And then go on the go right here. We will become CH2, CONH2. This is asparagine. And then go CH2, CH2, go C, O, and NH2. This is glutamine. Remember, sodium glutamate, you like it. We make the soup. And then the one is, go to here, we have OH, and then CH2. It is called tyrosine. Okay, this is finished the second group. Then we go third group. Third group, we're using hopefully using a red one or blue one. Third group is a polar, but then charged. And of course, it's a hydrophilic. Okay? Now, it's very simple. When you see asparagine here and glutamine here, then you're very natural, you're going to come out with two. What is that? Aspartic acid. It is negatively charged because it's acid. So next one is glutamine. You're also going to be very easy to come out with two. CH2, this is glutamic acid. That's also negatively charged because it's an acid, okay? Then we go down for three basic ones. What are the three basic ones? The first one is, this one is always tricky to draw lots of the time. It should be NH, NH. Go here, then CH2. This is histidine. Okay, then the second one, it's a very long. CH2, CH2, CH2. We go here, CH2, then become NH2. What is this? Lysine. A lysine, we mentioned, it is an epsilon amino acid. We call it an epsilon amino acid. That's why this is easily to react it with lactose or glucose in the milk powder. So we call it a Maillard reaction. Is that right? Maillard reaction. It's easily to be reacted for lysine. Last one, we have CH2, CH2. Let's go here, CH2. Then go NH. Then we have C, NH2 plus, then NH2. That is arginine. Arginine. And I said there is a joke for HL. So what is we call it? It's a joke. His or her letters are basic. Histidine, it's L, lysine, A, arginine. These are basic positively charged amino acid. Okay, so these three go here are basic, positively charged. That's all. 20 points. Can you get it? That's all there. Okay, so I'll take a picture, and you guys gonna be recorded. Even you don't know, some of them you should know. Is that right? Glycine you know, alanine you know. Is that right? 2 points. Phenylalanine just add a phenyl group. Do you know that? You may don't know tryptophan. That's understandable. Serine is easy. Just add OH. You see these things are easy. This add OH, then you add CH3, add cyanide, it become H. Okay, asparagine, glutamine, if you know aspartic acids, glutamic acids, you know it. Is that right? Lysine, you should know. It's very easy. Maybe arginine a little bit tricky. You don't know. Histidine is always difficult because that's a 5 carbon. It's a pentose. You know, it's usually difficult to draw from the biochemistry standpoint. At least you know the joke. Histidine, lysine, arginine, and the basic. Is that right? This is like we make a joke for the person who wears the long boots and hanging around the campus, but they not study very well, just show off the dressing. Is that right? That's why like his or her leggings are basic. Okay. That's a joke in 1990s when people learned about amino acids, how to remember it. Okay, so just want to show you what we have, and then we'll talk about the others. Okay, so